Hi, and welcome to the video on reciprocal functions. We're asked to sketch the graph of y equals 1 on the function, where the function is x squared plus 2x minus 3. Then we're asked to find the domain and range. To do this, we're going to sketch the function. I need to know what my roots, my y-intercept, and my minimum turning point is going to be of my function. So to work out the roots, I need to let y equal 0. That is, x squared plus 2x minus 3 equals 0. I'm going to factorize the left-hand side, and this gives me two values for x where y equals 0. These are my roots, or where the graph will cut the x-axis. Next, I'm going to find the y-intercept, and to do that, I'm going to let x equal 0. Subbing x equals 0 into my equation, I get y equals negative 3. So it's going to cut the y-axis at 0, negative 3. To find the minimum turning point, I need to know where the axis of symmetry is. Because it is a parabola, we need to work out what is halfway between our roots. That is where x equals negative 1. So when x equals negative 1, y equals negative 4. Now I have all the points I need to sketch my graph. Let's go do that. Okay, here I have my number plane, and I'm going to graph the function x squared plus 2x minus 3. I have the roots at minus 3, 0, which is right here. And I have my other root at 1, 0 here. My y-intercept is going to be at 0, minus 3, and my graph is going to have a minimum value of minus 1, 4. So let's take a look at that graph. We're going to draw it in. We're going to make sure that the graph goes through minus 3 on the x-axis. It's going to have its minimum point at minus 1, 4, cut through the y-axis at 0, minus 3, and up through the other root at 1, 0. That's the graph of the function x squared plus 2x minus 3, and this is going to be a good start for us to draw the reciprocal function. Now, for our function, when f of x equals 0, we get two roots, minus 3 and 1. If we find the reciprocal of that function, then we get a fraction that is 1 over 0, which can't exist. We can't divide by 0. So on our graph, it will create asymptotes. So we have asymptotes at our roots of our normal function. So we have an asymptote at minus 3, and we have an asymptote at x equals 1. Now, all fractions can't equal 0. If there is a positive number on top, it will not be able to be equal to 0. So y will not be able to be equal to 0, which means that we create another asymptote at y equals 0. So our function that we're going to graph, our reciprocal function, will not cut through these lines. So now what we want to do is work out what happens to our reciprocal function between negative infinity and negative 3, negative 3 to 1, and from 1 up to infinity. As you can see from our function, as x gets closer towards negative infinity, as it gets smaller, the values of y get bigger and bigger and bigger. They tend towards infinity. This means that our reciprocal function as x gets closer to negative infinity will be 1 over infinity. Let's see how that looks like. So as our reciprocal function gets closer, x values get closer and closer to negative infinity, the y values get closer and closer to 0. They'll never cross, but they will stay on this side of the asymptote. Now let's have a look and see what happens as x tends towards positive infinity. For our function, as x gets bigger, y also gets bigger and tends towards infinity. For our reciprocal function, as x gets bigger, y is going to tend towards 1 over infinity, which again is going to be a very small number, but it's not going to be negative, so it's going to get closer and closer to 0. Here's what that looks like. So as we get bigger and bigger, we get closer and closer to y equals 0, but we never cross. As we approach negative 3 from the negative direction, we can see that our function is all positive. This means that our reciprocal function will also be positive. It'll also stay up in this section. So as our x gets closer towards negative 3, let's have a look at what it looks like. It's going to get closer towards that asymptote of negative 3, and it's going to stay positive. The same is going to be true for the right-hand side over in this section. As we get closer to 1, you can see that as our function gets closer to 1, it remains positive until we get to the asymptote at 1. Here's what this is going to look like. So we're going to get closer towards the asymptote, but we're never going to actually cross. Now that it's all left to do is to join up our graphs. So on the left-hand side, it looks like this, and on the right-hand side, it joins up to look like that. Now what we want to do is work out how a reciprocal function behaves between negative 3 and 1. To do that, we take a look at our function and see how it behaves as it gets closer towards -3. You can see that all the values are negative. This means that our reciprocal function will also be negative and tend towards -infinity, and this is how it looks. It gets closer towards that asymptote but tends towards -infinity. Similarly, as we get closer to 1 from the negative side, our values are also going to be negative for our function. So our reciprocal function will also be negative. And here's what that looks like. So all that's left to do is to see how our reciprocal function behaves between these 2 points. Now between these 2 points, our function goes through a vertex at -1, -1, -4. So our reciprocal function will have to go through -1, -1/4. So our graph is going to go through that point and create a maximum turning point. And that is the graph of the reciprocal function. The second part of the question asks us to find the domain and range of the reciprocal function. From our graph, we can tell what the domain and range is going to be quite easily. We know that the domain will be all real x, but we have those two asymptotes at -3 and 1, so x can't be -3 or 1. Using interval notation, we write it as -infinity to -3, with the union of -3 to 1, and then the union of 1 to infinity. For the range, we look at all the y values that where our graph exists. So y only exists for values less than -1/4, and for values of y greater than 0, but don't include those values. Using interval notation, we can see that our range will go from -infinity to -1/4 with the union of 0 up to infinity. And that's the sketch of the reciprocal function and how to draw it, and also what its domain and range is. Good luck.